Hey guys, it's Mr. Hawkrotter with South Gibson County FFA in Madonna, Tennessee. I just wanted to kind of give you an idea of what our SGC FFA agriculture classes have been doing over the last couple of months. The kids have been researching and designing their own hydroponic systems. And as you can see here, we have what we call a rail system. And it's pretty much just a 100-gallon, watering trough for livestock that we have attached a sump pump that we got off of Amazon, just a little cheap sump pump, and we've got it coming up. And unlike traditional rail systems that I've seen by like MP Gardner and a couple other of those YouTube guys, we don't have individual hoses or one individual small 16mm line running to each individual rail. Instead, we decided to go ahead and just take the 3/4 inch outlet that's on the sump pump and go up to a manifold and create an entry manifold for all of our nutrient-rich solution. The nutrient-rich solution will then, just by the force of gravity, go into each individual rail system. And you see here we've got it all numbered. We haven't got anything planted in it yet, because we've still been, kind of fine-tuning this thing. But, the way that it sits right now, it's 20 feet long, and we are able of producing 72 heads of lettuce out of this 120-foot, section of table right here. If you look down here, you'll see the end where we have our outlet manifold. And I just dry fitted this thing together a couple of minutes ago. It's not glued by any means. So if you see any water dripping, it's because it's not watertight right now. I didn't want to glue it until we went ahead and ensured that it is properly working. One of the issues that we had earlier that we weren't exactly sure how to circumvent was, instead of having these 3" by 1.5" reducers right here, we just took some 3" end caps and drilled some holes into the end of it and had a piece of 1/2" pipe. Now, you would think that that would be plenty of space, because a 1/2" here, a 1/2" here, there, and there totals up to 2 inches of pipe space where the water should be coming out of, and we only have a 3/4 inlet up there coming off of the sump pump. So, if you're taking in 3/4 inches of water, and you're being able to relieve 2 inches of water, you would think that you wouldn't have an issue there. But our rail system kept overflowing, and we were losing our nutrient solution test mix, and we could have possibly burned up the pump had we let that continue. So we went ahead and decided to put a little bit more money in from our grant into this, and we went ahead and changed it all over. We cut the caps off, and we just got some 3" by 1.5" reducers. Once we got the reducers, we decided that we could control each individual line and the height of the water in each line right there if we put the valves on the outlet manifold instead of on the intake manifold. We did that for a couple of reasons. One, we didn't want to have the pump having any additional pressure on it. Anytime you restrict the flow coming from a pump, you're going to increase the pressure and have the wear and tear on it. Also, we just thought that it would be better to put them down here so we could control the height. And, if our situations were to change or, whatever, it'd be easier to control this end of it than it would be the other end. As you can see, that is our rail system. It's pretty good for student engineering. I'm very interested to see how this continues to develop over the next semester when we come back in the fall of 2016. But as you can see over here as well, our students also were designing a floating hydroponic bed system, and this one was relatively easy to develop. We have a steel door manufacturer locally in McKenzie, Tennessee, Republic Doors, and they were able to come across a couple of sheets of styrofoam that they sold to us at a really good price. And we took the styrofoam, and all it is on the bottom, the very, very bottom board right here, is just a piece of your cheap traditional cheap traditional OSB board. Well, and you say, well, wait a second. OSB is not water, it's not compatible with water. Why would you ever do a hydroponic system with OSB? Well, cost was one thing, and secondly, OSB is, as long as you have a seal around it to where water can't get to it, it should be perfectly fine. So we got our OSB in a couple of 2x10s and 2x8s, and we actually created a box with the OSB on the bottom side of it, and we took just regular 4mm construction plastic that you would get at Lowe's or Home Depot, and we lined the entire box with the liner, and then we sealed it down with just a couple of pieces of stripping right here. This is just a little 1x, as you can see, and we put some screws and some nails into it. The kids had a good time perfecting those skills. And once we put the liner in there, you're going to make sure that you fill it up. You're currently filling it up while you're trying to secure this down, because you want to get as many wrinkles out of it as possible. And once we got all the wrinkles and everything out, it was pretty simple, actually. You take the formula from the liquid fertilizer or the granule fertilizer that you're using, and you just mix it with X number of gallons of water. And with the size of the units that we have right here, we have 2 of them, but we only have 1 planted. As you can see, we've been kind of doing an experiment to see how well a cucumber plant would grow in the nutrient-rich lettuce solution, as well as a corn plant. And our sweet corn plant was doing really well until about 3 or 4 days ago, and I can tell now that we're starting to lose the nutrients that this individual corn plant is supposed to be getting, because this is not a corn solution. This is a solution mix that is made for hydroponic lettuce. But it seems as though that our cucumber plant is doing fairly well. But once you've gotten all of your materials together and you start filling it up, it's going to take about 100 gallons of water. 100 gallons of water, put that with your mixture of nutrient solution, and then, take your styrofoam. We chalked it off, as you can see right here, to make sure that we had adequate space between our heads. But once you put all that on there, and you drill your holes, you take your little cups, your little plastic cups. It's the same cups that we're using in our rail system over here, the little 2-inch net cups. Take your little 2-inch net cups, put down in there, and just take your lettuce seed that you started. We started ours in some like Oasis Roto Cubes, and it's done really exceptionally well. I can't complain about those whatsoever. They're a little expensive, especially for a small mom and pop or somebody that's trying to just do their home garden. It's about $100 for a case of 1,000. But I mean, for the school, we could take care of that. But it's doing very, very well. And as you can see, our biggest plants are the ones that have been here the longest, of course, and they're doing really, really well. The last plants that we planted were these on this end, and we just put them in there about 4 days ago. And they're already this size. Lettuce takes about 55 days in order to come into maturity. But hopefully by the time that these kids get ready to graduate in May, we'll have some heads of lettuce in order to let them see the fruits of their labor. As our lettuce crop continues to grow, we're going to start utilizing our other floating bed. We've already started putting some over there, but we've got to get the lettuce sprouts to a certain viable size in order to plant them. But we're hopefully going to have this rail system up and running too, because I would love for the kids to be able to see the actual culmination of all their hard work, dedication, and research as it comes together, and let them taste what all that hard work can produce. Well, guys, that's pretty much it at the SGC greenhouse right now, other than our plant sale that we've got fixing to start up April the 1st. This is pretty much our vegetable production. Well, with one caveat, let me add, we're also in the process of establishing our Beto buckets over there. In our Beto buckets, we're going to be growing our cucumbers and our tomato systems. We've got our tomato trellises already set up and ready to go. Just got to do a little bit of repair work on our tank over here. It's not watertight, but that's no big deal. We can get that taken care of. But, hopefully by the middle of next week or so, we ought to have our tomato plants in there growing as well. Well, that's all I've got, guys. If you have any questions at all about our program that we have here, or any design details about this particular system, any of the systems actually, feel free to email me at hawkriderd@gcssd.org, That's HOCHREITERD, as in dog, at GC, Gibson County, Special School District, SSD.org. Thanks, guys, and I look forward to hearing from you.